Hello everyone. Welcome to section 5.1, Energy Basics. This is the first section in Module 5 on thermochemistry. I want to talk about some of the learning objectives here. We will be breaking this section down into a few portions, so I will just talk about the learning objectives that we'll cover in this first video. Define energy, distinguish types of energy, and describe the nature of energy changes that accompany chemical and physical changes. Distinguish the related properties of heat, thermal energy, and temperature. And then the remainder of those will be things that we cover in a separate video. So energy is important to understand in the context of chemistry because matter changes in some very important ways that involve energy. So there are some examples here from your textbook. So when you eat food, you are getting energy out of the food by causing a chemical reaction to take place on the food to turn it into some other form. As you digest it. Of course, we use energy in our vehicles to get places, and again, a chemical reaction is taking place for that to occur. And then there are processes for refining various things that involve energy to change it from one form into another. So energy is a very important way that we need to consider how matter changes, and we'll be learning that within this chapter. So what we'll be looking at in this chapter is something called thermochemistry, and it is an understanding of how heat might be either absorbed or released during chemical and physical changes. And it can be thought of as a subset of a larger concept called thermodynamics, and we'll be exploring the rest of the thermodynamics in more detail in the second semester. So energy can be defined as the capacity to supply heat or to do work. So those are introducing two ideas, and we need to discuss what we mean by heat and work. So work is something in science that we define as movement against an opposing force. So it's not work in the sense of you show up and you clock in and then you clock out. You will be doing work whether or not you're getting clocked in and out for it. But in the sense of science, we're looking at movement against a force. This is an idea that you will explore in much greater detail if you take a physics course. We'll look at it slightly in here, but we want to have a kind of somewhat of a broad understanding of energy in order to get into some specifics related to thermochemistry. We can think of energy as falling into a couple of categories. In fact, we can essentially put all energy into one of two categories. Those are potential energy and kinetic energy, and we're looking at those here. So potential energy is energy that something has based on its position, and that could show up in a variety of ways. It could be position relative to another an atom's position relative to another atom, or it could be on the macroscopic scale, as we'll see here in a minute. And then the other type of energy is kinetic energy. Kinetic energy is an energy of motion, so it's an energy something has because it is moving. We can think of potential energy as energy that it would be moving if something were to change, and kinetic energy is when that movement is actually occurring. So kind of a classic example of these two types of energy would be looking at the movement of water downhill. Here we're showing a waterfall. Um, and in this waterfall, we have the water is moving. It has energy because of that movement. So what's happening is we have the water at the top has potential energy because it's higher than the water at the bottom, and then we have a lot of kinetic energy as it falls. So it starts to move faster. So we're converting from one type of energy to another. Here we're showing a way that this type of energy is often harnessed with a dam. So we have potential energy up here, more potential energy up here than we do down here because of the change in elevation. But what happens in this case is that to get from here to here, the water is passed through a system that converts that energy into electrical energy, and that can be thought of as a kind of another source of energy that we are able to harness. So the idea of energy capacity to supply heat or to do work is useful, but also somewhat abstract when we first learn about it. So just be aware of these kind of types of energy that are possible. One thing I do want to mention here is that we have conservation of energy similar to conservation of mass. So we'll get into this in a bit more detail in a bit later in this module. And it turns out there's actually a relationship between those two, so we can actually convert between mass and energy. But that's something that we'll explore in greater detail in the second semester when we talk about nuclear chemistry. For now, we can assume that we can conserve energy and we can conserve mass, and most of the time those assumptions work fairly well. Okay, so let's kind of move more towards our idea of thermochemistry by defining a few more things that will be important. So thermal energy is actually a type of kinetic energy because it is about the movement of things. The movement, though, in thermal energy is very random. So unlike, say, a moving car or a person running or a ball, someone throwing a ball, those are all movement where all of the matter within the substance is moving together. When we have thermal energy, it doesn't work quite that way. In thermal energy, the matter within a substance is not moving together. It's moving in different directions. And there's a random kind of movement going on. We can think of this as a vibration, as one way of understanding this type of movement, where the molecules or atoms within the substance are moving relative to a fixed space, and over time they don't seem to move, but there is a movement there. The more vibration that is occurring, the more the thermal energy of that substance we will have. We can think of this as being hot or cold. So something that is hot will have more vibrations of the molecules that make it up. Something that is cold will have fewer vibrations of the molecules that make it up. We can actually measure this vibration by measuring temperature. So temperature is how we measure thermal energy. And when something is increasing in temperature, what's happening is that it is the molecules that make it up are moving about more than they would have otherwise. So that is how we measure thermal energy. There are some, let's see, this one here, there's a simulation you can look at with regards to temperature and molecular motion if that is something you would like to explore a little bit more. So we measure temperature often by looking at something changing its size. Most things will, because they're vibrating more, will increase in size somewhat as their temperature increases. So with a thermometer or these are things that in the past may have been used for a thermostat. I don't know that they do that anymore with the digital ones. But these are ways in which we can measure changes in temperature by measuring the physical properties. So this idea of thermal energy is a measure of the movement of the random movement of the particles in an object. Um, Kind of the final piece of that puzzle is this idea of heat. So heat is an important concept in chemistry. Let me redo that. Okay, so heat is an important concept in the study of chemistry and thermochemistry, and that we're looking here at the transfer of thermal energy between two separate objects that are at different temperatures. So where we have two objects at different temperatures, one is at a higher temperature, the molecules are vibrating more. When it's at a lower temperature, the molecules are vibrating less. As we put them in contact with each other, what will happen is that energy flows from the one at a higher temperature to the one at a lower temperature. And what happens there is that the molecules at the higher temperature start to vibrate a little bit less. The molecules at the lower temperature start to vibrate a little bit more, and eventually they end up at the same spot. So we call this a thermal equilibrium when the two objects end up at the same temperature. Okay, so heat flows from high temperature to low temperature, and that heat flow is a transfer of thermal energy, and that will happen until they end up at the same temperature. This is a concept that we will be exploring through a few additional videos, so we're not done with it yet. We're just kind of introducing it. We'll put some numbers on here, not in this video, but in the ones to come. Another simulation here on looking at energy and changes, so I'd recommend looking at that as well. I want to end this video with a few additional definitions for some of these changes that can occur. So we can have a process within an object where we are either releasing or absorbing heat. So this is often due to either a chemical or physical change. So we have some terms here. So we have what's called an exothermic process, is a change that will release heat to the surroundings. So heat is coming out of the object or the place where the change is occurring, going into its surroundings. So an example of an exothermic process is we're showing here an acetylene torch. There's a chemical reaction going on here, and as that reaction is occurring, energy is coming out of the bonds in the molecules and going into the surroundings, and the surroundings will experience that as this torch basically is increasing the thermal energy of the surroundings. The opposite of that is an endothermic process. So an endothermic process is a process that is absorbing heat from its surroundings. Again, so that this is either a chemical or physical change going on in a substance that will absorb energy. Cold packs, chemical cold packs are examples of this, where you shake or bend or break something, and then as that happens, chemicals come together in a way that they want to absorb energy, and that cools off their surroundings. So we can have exothermic or endothermic processes. You want to know the differences between those. We're going to go ahead and leave off here on this video. The next video will discuss some of these same ideas more quantitatively in terms of how we go about measuring these things.